Hey everyone, welcome to this week's episode of the Health via Modern Nutrition HVMN podcast. This is your host, Jeffrey Wu. And we have a continuation of our research roundup talking about some of the latest research papers on exogenous ketones, particularly ketone esters, and on this specific cadence, talking about ketones and heart health. And to join me to discuss the exciting papers is HVMN's research lead, the powerful Dr. Latt Mansoor. Good to have you on the program.
Hi, Jeff. Good to be back. Excited to speak about this paper because it's actually clinical.
Yeah, it was good to see you this past weekend. You were in Miami, but now we've disseminated across. I'm currently in Puerto Rico, so new backdrop. You're back in California, so even further apart in the world, but our minds and our attention are here together. So I'll hand the mic to you. What paper do we want to talk about today?
So this paper is entitled Myocardial Ketone Body Utilization in Patients with Heart Failure, the Impact of Oral Ketone Ester by Monzo 2020.
So again, if you've been following along on previous research roundups, we've been talking about ketogenic diet, exogenous ketones, and heart. Again, I don't want to rehash the previous threads, but when some cardiologists think about the ketogenic diet, they think, oh, high fat, maybe high fat is higher risk for cardiovascular disease. Of course, we've covered that topic a lot where what are the pros and cons of that argument? Is ketogenic diet good or bad for heart health and heart risks? But the great thing about exogenous ketones is that we totally throw out the fat diet confounder. You can get the similar levels, if not more extreme levels of ketones without having to do a ketogenic diet. So we're really measuring the impact of ketones themselves. So I think what's especially exciting about this particular research is that this is on humans. So last time we talked about rats and mice, and today we're going to extend out to humans. Let's talk through the research group, the researchers. Do we know them? Are they good people? And a little bit about the setup.
I don't believe we have had any contact with them.
But did we supply HVMN to them? I think we might have been the supplier, so it must have been.
Yeah, it's a group it's a combination of authors from Czech Republic, Sapienza University in Rome, Italy, as well as Mayo Clinic, Rochester, Minnesota.
So they must have just bought this our product off the commercial market. So very, very cool that our consumer products, which are of course super high quality, are research grade. So credit to our product development team to produce high quality research grade foods that top tier academics can be using for their research. Cool. I'll let you take away on the setup here.
All right, sure. Let's start with the methods. So this paper, as it's mentioned, it's looking at the patients with heart failure. So 19 moderate heart failure and reduced ejection fraction patients were tested, as well as 9 controls. So 19 heart failure patients, they have reduced ejection fraction, and 9 controls. There are 2 groups. One group was studied only after fasting without any intervention, while the other group, group 2, studied 18 minutes after drinking 25 grams of ketone ester drink. So we have essentially four different arms here. We've got heart failure and then control patients. And then we've got group 1 with intervention, group 2 without intervention. And then arterial, venous, coronary sinus bloods were taken and analyzed. So this is one thing I want to focus on here a little bit more. The fractional extraction is the measurement that they use here, and it will come up multiple times during our discussion. So fractional extraction is essentially a percentage of substrate that is being utilized. So the way they measure it is that they measure the substrate going in, and then they measure the substrate going out via the coronary sinus, which is a collection of veins joined together to form a large vessel that collects blood from the heart muscle. So essentially, how much of a certain substrate is extracted by the heart from the blood coming in from the artery and then coming out via the coronary sinus. So this is the fractional extraction percentage.
Great. And the key, and I like to just make sure that, is relevant for people, especially this is a human study. So in terms of translational audience here, so we just said a lot of kind of scientific terms. How does this apply for me if I'm concerned about my heart health, or I have loved ones that have a history of heart disease, or maybe have already had a heart attack? Now, what is the kind of the key endpoints that all these things are proxies for?
I think this paper particularly highlights the different substrates that's used in the heart. The heart is an omnivore as we know it. It uses carbohydrate, it uses fatty acid, it uses ketones. So this paper basically measures how much of each substrate is being used, especially in the heart failure patients. So I think that knowledge is helping us to understand, okay, what sort of substrate is actually useful if you are at high risk of heart failure, for example. Unfortunately, though, this paper did not measure specific function, heart function that is relevant to heart failure, like ejection fraction and gas exchanges and all that. So we're just looking at substrate utilization here.
So directionally useful in terms of what the heart kind of craves in a damaged state.
Correct.
Which gives us a hint or hypothesis of does this translate potentially into a functional measurements, right? So again, to the point, just to make it more explicit, would be like, oh, after a heart attack, would someone with exogenous ketones or ketone esters, would their heart recover faster and have more ejection fraction or pump more blood versus someone on with no ketones or a control? So this study does not quite go there. It's like, a step before in terms of the metabolic substrates. Cool. So let's talk through a little bit on the enrollment and size. I know you mentioned the different arms, but I think worth it to just talk through a little bit more detail before we talk about results.
So as I mentioned earlier, 19 heart failure patients with reduced ejection fraction with 9 control patients. So these patients essentially went through the same protocol. Either they are being treated with intervention, i.e. 25 gram of ketone ester, or just fasted. So we have heart failure fasted, heart failure with intervention, control fasted, and control with intervention.
Got it. Cool. And essentially, it's unclear how the groups were selected, but was it crossover? Or do they try both interventions on both ways?
I would assume it would be crossover given the numbers, especially for the control, is quite low. So I doubt they will sort of divide the number into different groups just for the controls.
Okay. So again, maybe feedback for the authors. We love to get clarity on exactly the sizes, but we're going to just assume for this discussion that was a crossover, and it reads probably right to me in terms of typical N sizes that you would need enough N here to make strong statistical conclusions.
Absolutely, you're right. And also from the point of view of the design of the study, because they're just looking at utilization of substrates, so they can have a washout period and use the intervention and still can see the difference in utilization of substrates, because this is not essentially a irreversible intervention.
Cool. Yeah. So basically, it's a heads-up competition: fasting versus ketone esters, exogenous ketones, and seeing how heart failure patient versus a normal patient, how they respond to these two interventions. So, without further ado, what did we learn here?
All right, great. Let's go straight to the results. So I'll cover a few results that we already expect. So the KE group, the intervention group, has increased blood BHB. The blood glucose decreased, but not significantly. There is decrease in triglycerides and free fatty acid in both groups, the heart failure and the control who took ketone ester. And following ketone ester drink, they observed a slight but significant reduction in peripheral venous pH and serum potassium, which is what we know of. We spoke of in previous podcasts where KE actually increases the acidity of the blood. Now, to the more interesting finding of this paper is that higher ketone ester delivery or high-end ketone body delivery unmasked an increased capacity to utilize beta-hydroxybutyrate in heart failure group. So what it means here is that in the heart failure group, the fractional extraction before they took ketone ester is quite low. So we can say that it's not that useful, or ketones are not that useful for metabolism in heart failure group, just fasted. But then when you deliver ketone ester into the heart failure group's myocardium, it actually increases the metabolism and utilization of BHB. So that's very interesting.
So why is that? So what was the BHB level of the fasted group?
So if you look at figure 2b, if you scroll all the way down of the paper and look at figure 2b, you can see the millimolar of ATP per liter of blood. So we can see that after KE, both heart failure group and control group actually increase significantly. But I believe in terms of numbers, the heart failure group, the increased percentage versus fasting is much higher compared to control. I believe the number is around 50% to about 39%.
Yeah, I mean, isn't that expected? Because look, I'm just looking at the β-hydroxybutyrate for drink versus, I mean, there's just like very low BHB. Like, how long were these people fasting for? Just overnight fast?
Just overnight, yeah.
Yeah, so I think to me, it's not that surprising. Just overnight fast for a normal person is not going to have that much BHB. I mean, so like my argument, my conclusion here is just a little bit. I would just restate the point there differently, which is that when there is high level of presence of BHB, it gets readily metabolized by the heart versus fasting, because essentially an overnight fast for a non-ketogenic person is going to have very, very low ketone levels. So there's just not that much BHB to metabolize in the first place.
Yes, you're right. So there's the question of availability, but there is also the question of efficiency. So I think what the point that they're trying to drive here is that in the heart failure patients, without the availability of ketone bodies, the utilization rate is quite low compared to control. But then once you have availability, the heart failure actually prefers ketones and really increase utilization, both uptake and oxidation of ketone bodies. And this is also unaffected in terms of glucose and free fatty acid. That's another point. So even though the increase in fractional extraction of BHB increase, it is not affecting the other substrates. So they can argue that there is no competition. So it's not that they downregulate glucose or free fatty acid and then upregulate BHB. It is on top of.
So one can make the argument that there's a preference for heart failure patients to for the cardiomyocytes to use ketones. It would be one way to say it. Although, just to be fair, on the contrary side, one could argue that for some reason the body wants to metabolize away beta hydroxybutyrate because it's just in there. Just like how alcohol ethanol is oftentimes preferentially metabolized because it's a toxin. Why can't we make that conclusion that, okay, BHB is in there, it's somewhat toxic, and now the body needs to get rid of it by metabolizing it?
Well, I mean, if it's toxic, then yeah, then that argument would go, right? But if it's not toxic, which we know it's not, then the only argument is that it's energetically more preferable to metabolize ketones.
Cool. Yeah, which is very consistent with our observations and previous literature in terms of why ketones are so interesting. So that's very cool that, especially in the heart failure patient, yeah, it's a substantial percentage of overall energy load. But but it's not even, I'm just looking at the graph now, it's not even dependent on a heart failure patient or a control patient. Both, even a healthy heart prefers beta hydroxybutyrate. So it sounds like the heart just loves ketones.
And that has been shown similar to our last podcast in the animals as well, of heart failure model as well as like control. They, regardless whether they are disease state or not, if you give them ketones, the heart will metabolize it, and it shows slightly better efficiency compared to other substrates.
Cool, which bodes well for a lot of like the human performance studies that we're involved with and keen about. Right, if it's healthy and damaged hearts preferring ketones because of increased efficiency, obviously that would show up on the therapeutic side and the clinical side, but also show up on the battlefield or in the sports field. Cool. What other key interesting results should we talk about here as well?
So I already spoke about the fact that there is no relationship between the BHB fractional extraction versus free fatty acid or glucose. So there's no competition. And then they also found that for free fatty acid and glucose, they are very much driven by regulatory mechanism of the heart of how much is going in. But apparently for beta hydroxybutyrate, it just goes up, and they didn't really see a threshold where there is maximum delivery of BHB being reached. So meaning to say that while other substrates is being gated by transporters and different channels, BHB seems to continuously being delivered into the heart as long as the availability is in the arterial blood.
So there's no cap. So ostensibly, would it be possible to have 100% energy from ATP or from BHB? Obviously, it doesn't like, it sounds like it's just like, it is a very clear linear dose response to the availability of blood BHB for heart utilization.
Correct. Whereas the others, they actually cap it.
Yeah, it's a pretty interesting mechanism, right? Like this is just like understanding like how cardiomyocytes or heart cells prefer. It's just like a pretty interesting piece here. So I mean, I think fasting is like pretty interesting because it's like a form of a ketogenic diet where instead of metabolizing exogenous fat, you're just metabolizing endogenous fat and stored tissue. So in some sense, that's why you see higher triglycerides, right? And free fatty acids in the fasting group versus the ketone ester group. So let's talk about the discussion, translational, and the application side now. So I think it just recapitulates a lot of the interesting discussion around ketones, not just being a great substrate, but potentially a preferred substrate. We know this is potentially the case for brain. It looks like this is a very, very good evidence for this to be the case for the heart. But I think the takeaway point is that, okay, if one is worried about heart failure, heart disease, would exogenous ketones be potentially useful? And I think through this paper, it suggests that it's definitely something that one can consider, right? I think there's much work to be done where let's actually measure ejection fraction. Let's measure the functional biomarkers of the heart. But I think the case that it is readily metabolized, readily uptaked by the heart is a very, very good sign. And I imagine that this research group is going to have a follow-up paper there. I mean, it's very, very natural extension. So I imagine that we will keep an eye on the Monzo group to see if they actually measure functional endpoints to further prove out this hypothesis.
Yeah, and I know cardiologists love their functional endpoints, so I'm very positive that is just a matter of time before we see some form of study that comes up with it.
So what would be so let's make this fun. Let's predict. So I would predict that ketone ester or exogenous ketones are going to improve the ejection fraction against isocaloric control, whether it's fat or glucose, in a post myocardial infarction or heart attack patient. That would be my hypothesis. You're going to get some 5 to 15% improved ejection fraction.
I mean, we have seen that in animal models already. So I'm definitely, standing by you with that hypothesis and prediction, whether it's translatable from the animal models to clinical trials, definitely is an interesting area to look into.
Yep. And then just on the ketogenic diet point, right? So I think the most important part of this study was that this was exogenous ketone. This was ketone ester that really elevated blood BHB to over 2 millimolar and up, right? So clearly an overnight fast does not generate that much beta-hydroxybutyrate. So if for folks that prefer endogenous ketosis or ketogenic diet, I think the key endpoint for that type of diet is elevating blood BHB levels. So if for some reason your blood BHB does not seem to be that high, you might not get the benefits, the heart protection that you see with exogenous ketones, which is very consistent in delivering high BHB. But I see no difference if one could fast or eat a ketogenic diet and elevate consistently high blood BHB. My hypothesis there would be there's no superiority or inferiority with the two interventions of elevating blood BHB. One just needs to get the blood BHB high enough where it's a dominant fuel for the heart.
Yeah, so one of the main finding of this paper is the fact that as long as you have ketone body in the blood, the heart will continuously take it in and utilize it and metabolize it. So if I am to extrapolate this into different disease states and different organs, which are caused by either the deficiency of the transport system of substrate into the organ or the deficiency in energy production, then ketones could potentially, or this could potentially be an explanation to the mechanism of action why ketones are very useful in these instances, like in myocardial infarction, in cognitive impairment because of reduction in glucose oxidation, for example. So the next step is to really, unpack that metabolic differences and regulatory mechanisms that allow ketone to be superior to other substrates in these disease states.
Yeah, no, I think it's a good point, right? There's, for some reason, it's uptaken very, very readily, and there's not seem to be a cap where other substrates that are more normal in foods seem capped out. So I think there's definitely a point there where it's not it sounds like on the high end, right? Maybe some efficiency gains, but I think the dominant use or the dominant reason why this is so useful from a therapeutic perspective is that there is no plateau. So there's less starvation in terms of energy starvation of these cells that might be damaged or taking damage through an insult or injury. So something interesting about this backup fuel where it just gets in there really, really readily. So much to unpack and much to follow here. So very fun paper. I think this is an especially good one because it's on humans. As we always like to disclaim, humans aren't mice, humans aren't cells, humans aren't C. elegans, nematodes, whatever animal model that we might like to have. So it's really great to see this replicated and those hypotheses extended into the humans. Now, really to make this translatable and have it more buttoned up in gold standard randomized controlled, right? Let's do heart attack patients. Let's do standard of care. What is the gold standard for post heart attack treatment in terms of both drugs or food and lifestyle? And let's add ketones, exogenous ketones as an arm. And maybe just also add a ketogenic diet as an arm as well. But I think that is a little bit more dangerous because with a ketogenic diet and or fasting, it's hard to elevate ketones that quickly. So, but I think it is to be a good scientist, we really want to further disambiguate the differences between exogenous ketones and ketogenic diet. So if I had infinite purview to just, run people like guinea pigs, I would have an arm for a ketogenic diet just to further disambiguate ketogenic diet, fasting, and exogenous ketones. But as we saw in this paper, the blood BHB levels seems to be the key marker here. There's nothing necessarily magic with the diet or fasting or ketone esters to be 100% clear. It's just getting high blood BHB levels where that can enter the heart and then be metabolized. So I think this is, again, super helpful to extend out our understanding here. As always, Latt, great to dive into the literature and dive into the science and get a little bit technical here. Any other last thoughts before we wrap up?
I was going to add on to what you were saying about, the future of research and disease states using ketones. And the benefit that we have in our generation is that ketones or exogenous ketones are food products. They don't have to go through billions of dollars of, drug development, and it's available. It's readily available. It's very affordable. So I think if we do find that it is very helpful for all these different chronic diseases, it's a win for the human race, essentially.
Let's help make that happen and support that mission. All right, I'll leave it at that. I think that's a great way to end here. So HVMN fam, thank you so much for tuning in. As always, reach out, email us, podcast@HVMN. We appreciate like, subscribe, bell button, comments, 5 stars. Appreciate your support. Talk to you guys all very soon.